Hey guys, today we're on Unit 9, Lesson 3, and we're going to be talking about the trigonometric sum and difference identities. Okay, so let's stop and consider for a moment the expression sine of 45 plus 60. Obviously, this is equivalent to the expression sine of 105, but the real question is, does the expression also equal the sine of 45 plus the sine of 60? So we're going to use our calculator to find the value of both expressions. When you do this, you want to be in degree mode. And we're going to find the sine of 105 degrees. And we get 0.966. Now take a second, even though we know we can set up exact values there, just take a second and do sine of 45 plus the sine of 60 using your calculator, and hopefully you get 1.573. So what conclusion can you reach based on the calculations above? Well, basically the conclusion is that the sine of 105 is equal to the sine of 45 plus 60. The sine of 105 is not equal to the sine of 45 plus the sine of 60. Okay. In other words, we can't distribute when we want to evaluate something like this. So let's jump down here for a second. Use the formula sine of A plus B equals sine A cos B plus cos A sine B to find the value of the sine of 45 plus 60. So if we were using this formula, right? Sine of 105 is the same as the sine of 45 plus 60. And we can find this value without using a calculator because we can evaluate this using our special triangles. So I would just substitute the information into the formula. And I know the sine of 45 is radical 2 over 2. Cosine of 60 is 1/2. Cosine of 45 is radical 2 over 2. And the sine of 60 is radical 3 over 2. Radical 2 over 4 plus radical 6 over 4, which is radical 2 plus radical 6 over 4, which if you evaluate this number in your calculator, I might as well do that. So I have radical 6 plus radical 2. I did it out of order, I'm sorry, but it's gonna wind up being the same thing. Hit enter, and I'm gonna divide that value by 4. I get 0.966, which matches the answer we got in the beginning of the problem. So today we're going to talk about how we can use what we call these sum and difference identities to find exact values when we're dealing with angles that we can't deal with without using this method. Okay. So for instance, find the exact value of the sine of 15 using two angles from the unit circle whose difference is 15. Well, don't really worry about that. We want to consider this, we want to just think special angles. We want values from our special triangles. Okay, can you think of any way you can add or subtract two angles together and get 15? I think there's two different ways we could do it. I'm gonna sine of 15. I'll use 60 and 45. Okay, you could use 45 and 30 as well. You would get the same answer. It would just look a little bit differently. So now I'm going to take and I'm going to expand this using my formula. Sine of 60 cosine of 45 minus cosine of 60 times the sine of 45. So now I'm going to actually physically put my values in. Sine of 60, cosine 45, cosine 60, sine of 45. Sine of 60, rad 3 over 2. Cosine of 45, rad 2 over 2. Cosine of 60, sine of 45. And now let's do the math to work this out. Radical 6 over 4 minus radical 2 over 4. And that's going to equal radical 6 minus radical 2 all over 4. We want to kind of express these as a single ratio. Find the exact value of the sine of 285 using two angles again. Some way that we can use two angles or that add up to 285. So we want to think about angles, basically multiples of our angles on our unit circle or multiples of our special triangles. How could I get the sine of 285? I want to think about what two angles would add together to get me that. I know I'm going to have to use a 45-degree angle. So I could probably do 240 plus 45. And I know that 240 is a multiple of 60, and 60 is on my special triangle. So I'm going to work out sine 240 cosine 45 plus cosine 240 times the sine of 45. So now here's where we really have to go back to last unit and think about what the sine of 240 is. Sine of 240 is really the sine of 60 in quadrant 3, cosine of 60 in quadrant 3. And we're going to substitute sine of 60 is radical 3 over 2. In quadrant 3, it's negative. Radical 2 over 2. Cosine of 60 in quadrant 3. Cosine of 60 is 1/2, but it's negative. Radical 2 over 2. Negative radical 6 over 4 minus radical 2 over 4. So this is equal to negative, I could factor that out, radical 6 plus rad 2 all over 4. There's probably different ways to express that answer, and that's okay. You could have just left them both negative. My goal here is to get you guys to kind of identify how to add these angles together to get what we're looking for. Now, I'm going to actually cut and bring my formulas down here so I can use them a little bit for the rest of this lesson. Simplify each of the following expression using a sign, sum, or difference identity. So when I look at this, I have the sine of x plus 2 pi over 3. So what I want to do is I want to expand this formula. Remember, this is your A and this is your B. Sine x cosine 2 pi over 3 plus cosine x times the sine of 2 pi over 3. Pi over 3, 60, so really 120. Sine x. Now what is the cosine of 120? The cosine of 120 is the cosine of 60 in quadrant 2, which is negative 1/2. And the sine of 120 is the sine of 60 in quadrant 2, which is radical 3 over 2. This one's not looking so pretty here. Negative sine x over 2 plus rad 3 cos x over 2. This one did not simplify so nicely, but it's okay. Again, we just want to work through the formula. Part B will be a little bit nicer. Let's look at B. B is a minus, so sine pi over 2 cos theta minus cosine pi over 2 times the sine of theta. This one's going to simplify a lot nicer. The sine of pi over 2 is the sine of 90. 1 times the cosine of theta. Cosine of pi over 2, 0 times sine of theta. So this expression is really equal to, this is just going to become 0, cosine of theta. In example C, now I'm basically looking at the right side of the equation, right? The expanded side. And I want to smush back it together to see how I could represent that angle. So in this example, I have a plus in between. Sine cos with a plus in between. Sine cos with a plus in between. So my angle A is 75. Plus B is 15. So this is really equal to the sine of 90 degrees. Sine of 290 cos, this time I have a minus in between. There's angle A, there's angle B. So now this is sine of A minus B, which is the sine of 240. So like in your future courses, you may be doing this type of manipulation to rewrite an expression so you can move forward. Now we went into great depth with the sine, the sum and difference formulas for the sine function. I'm just going to do a handful of examples to show you that it's going to be the same for the cosine function. So when we want to find the sum or difference of two angles, or the cosine of two angles, we're going to use our cosine identities. Cosine pi over 6, so this is my A plus this is B, and we want to find the exact value. Cos pi over 6 times cos pi over 2 minus sine pi over 6 times sine pi over 2. This is really the cosine of 30, 90, 30, 90. Cosine of 30, radical 3 over 2. Cosine of 90 is 0. Sine of 30 is 1/2. Sine of 90 is 1. This term is going to be 0. And when I evaluate this, the exact value is negative 1/2. Again, I'm going to show you one more example quickly of expanding this formula. Remember, anything we can apply or do with the sine, we can do with the cosine as well. So I'm going to substitute in, right there's your A. I'm doing cosine A minus B this time. Cosine 120, cosine 45, sine 120, sine 45. Cosine 120 is cosine of 60 in quadrant 2, sine of 60 in quadrant 2. Cosine of 60 in quadrant 2, cosine of 45. Sine of 60 in quadrant 2, sine of 45. Do your math. Negative radical 2 over 4 plus radical 6 over 4 is going to give me negative radical 2 plus radical 6. Remember, I cannot add radicals together if they're not the same under the radical sign. Now we're going to hop over the tangent for a moment. We're just going to try a different type of example, and we'll go back to the tangent on Monday or the next time we have class. Okay, let's look down here. Suppose that sine of theta is 3/5. Sine of alpha is 5/13. Additionally, so here's my given information. Tan. First thing I want to do is I want to draw the angles for theta and the angles for alpha. That's just a way to represent an angle. Labeling the reference triangles. Then I want to, now we only did the sine and the cosine so far. So we're going to find those values. Okay. Sine of alpha, so I need to set up my triangle for each. So if I'm setting up the reference angle, right, if I want to draw this angle, the sine is positive and the tangent is positive. So theta is going to be a first quadrant angle. Remember, all students take calculus. This is how we're going to narrow down our quadrant. Opposite over hypotenuse. Now, if you can't see that this is 4, because this is a 3, 4, 5 triangle, you can use the Pythagorean theorem. So there's my information for theta. Now let's do for alpha. Alpha, sine is positive and tan is negative. So this angle is going to be in quadrant 2. And I have opposite over hypotenuse. Now, hopefully you guys can see that this is a 5, 12, 13, and I'm labeling that negative because it's in the negative part of the x-axis. So once I have my side lengths, I can find any value. If I want to find the sine of theta plus alpha, the first thing I want to do is remember what my formula is. I thought I brought it somewhere. So there's a plus in between, so I'm using the top one. So it's going to be sine theta cosine alpha plus cosine theta sine alpha. And what we're going to do is we're going to take our values right from our triangles. So even if we don't know the value of the angle, we can still evaluate the sine of alpha, 3/5, of theta, the cosine of alpha, negative 12/13, plus the cosine of theta, adjacent over hypotenuse, times the sine of alpha, which is 5/13. And now we work through the rest of this math. Multiply across the top, across the bottom, and negative 36. Now I can combine in the numerator. I get negative 16/65. And we're going to do the same thing one last time. Cosine. So we're going to plug into this formula. Where's my cosine? Bring this down. Again, it's really just a matter of substituting into your formulas. So cosine A minus B. Cosine alpha, cosine theta. Just very meticulous. Sine alpha, sine theta. And again, I don't know the actual angle, but I could set up the function value. Cosine of alpha, adjacent over hypotenuse. Cosine of theta, adjacent over hypotenuse. sine alpha, opposite over hypotenuse, sine theta, opposite over hypotenuse. Work through the math. And I believe this is negative 33 over 65. So for the sine and cosine, for the sum and difference identities, we did a little bit of evaluating. We did a little bit of using it to show an identity. And then we did a little more structured evaluating where you have to be a little more detail oriented on how you set up your information. Okay, so we'll work more on this next time we see each other. Thanks and have a good day.